Hi my friends, today we model this part which has an interesting core inside and other features which are waiting for you to model. The source comes from Timoteo Carrera Soto. As usual, the name is Mirillas para Vapor, and you see details. This is the assembly, and we model this main body of this assembly. You see here something interesting, which are dimensions here. You have your eyes, your own eyes, to see here and to try to model. Just try to model and then take a look at my procedures to learn something interesting. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. I want you to read this advice, which is worthy of being followed. Don't wait for me, my friends, to deliver more and more tutorials, because you already have over 300 tutorials waiting to be watched. This is my drawing. It is not simple. You see here also a detail of inside the part. I work very hard to create these drawings, so I ask you again to go back and see the other models, because I will cease this activity in time. Okay, let's model this very part. New standard millimeters IPT, start sketch. This plane is for the new sketch. The sketch contains only a circle with diameter of 55, finish sketch, and an extrude symmetrical from the center plane with dimensions of 40. Now we focus on this wall, you see, which has a thickness of 4 millimeters, this dimension of 35. You see this 20, but you know that we made an extrusion on 40 millimeters symmetrical, so this is the center point, our center point. And we also see here this dimension of 5. Let's create this wall. We use the plane XY, F7, and I draw a line, this line, and another one parallel with this. You see, I hovered over this line, and now I have parallel line. The distance between them is 4 millimeters, as I said. I trim this extension and I project the axis Y. I make it construction, not center line, and I apply mirror of these two lines about this axis. Apply. We draw a line between these two and another one here. You see, this is not placed on the center point, so we use the coincident constraint to apply this. Let me see if this is 4. It is not 4. I copy it from here. 2 dimensions needed. This is 5, and this is 35. 35. And now I make something very, very interesting. I apply extrude of this area, symmetrical, all the way to the left and the right, and with intersection. Yes, we have that wall as an independent element feature of this modeling. Good. Now you see here there is a pyramid or a needle inside. Dimensions are here from this face to up is 24 minus 3. Okay, its dimensions are 8 millimeter up. This is 8 millimeter to here, and 10 millimeters down. The width is 10. Let's do this. The same plane XY, F7, line from this face up to the right, horizontal, and I try to place it symmetrical. Dimensions are 23 here, but I write 24 minus 3, which is 21. Yes, this is why we use expressions, because we are on a wrong way. We think many things and we make mistakes. This is 10. Yes. Is this placed on this line? Yes, it is. Good. I can draw a line here, and I make everything as construction to have no problems with the closed area here. Then I apply extrude, also symmetrical, on 10. Okay. This is the core of the part. We continue with creating this circular feature as a new body, a new solid. Dimensions are here. You see this contour, diameter of 72, thickness of 11, then a diameter of 55 to the bottom. On that base from the first cylinder placed here. Good. XY plane. We draw a line from this from the base to up as a center line. F7. It is not well placed, but we know the distance between these 2 points, which is 24. I place this line on the center point, and I force the end to be on the same horizontal with this line or point. Here is a point now. Then we draw lines, as you can see. Dimensions, this is 11, this is 55, and this is 72. Finish sketch. Now we apply revolve, but as a new solid. The first solid was that internal wall, and this is the second one. We use this as a base now, but I want you to see what is the other solid by changing its color to red. You see, inside this is that mid object or core, as I said before. Now we use this solid as the base for next features. For instance, this end, because this is symmetrical. They are symmetrical, the two. Okay, what are the dimensions? You see 110 here, then 67, 12, 3, and the distance of 150 50 with this middle axis. Okay, we use the same plane XY, F7, we draw a line of half of 150 divided by 2. This is the axis for the new feature. I forgot to mention that this is 50 and this is 30. You see this conical component of this feature. Line up and then we go to the mid axis of the feature. Dimensions, this is 67, this is 110, 3 between these two lines, 50 at this end and 30 at the other. Finish sketch, revolve, and we don't create a new object, but we want to join with this, not with the red one. How to do this? We select join, and Inventor expects us to select which of the two solids want to combine this feature with. I select this and I select this solid, not this internal solid. Yes? Okay. Now we apply mirror for this last feature about this plane. Okay. Now we have all the external volumes. I don't mention this. This can be made not visible because we don't need it until we finish with the internal or void spaces. There is an internal volume here, or we see better here, containing also this step. So let's create it. What are the dimensions? You see here 63, 43 and a depth of 3. Okay, we use the same plane XY for a new sketch. F7, I draw a line from mid to mid, then that step and down. These two faces were created. This is the close contour using this. I don't draw this line and this line. We have a center line here a diameter of 63, another diameter of 43, but I didn't place this endpoint on the projected line. This is 3 millimeters, and this must also be trimmed in order to have limits. Fully constrained, finish sketch, revolve, cut. Okay. We continue with creating these 3 features. You see this one, and this one. And then we apply that internal volumes, because if not, these two are inside of this face. Yes, I tried this and I saw the problem. You see here, this corner, when we apply extrude to create this. What are the dimensions? They are here: radius 6, radius 8, and metric 7 is the hole placed on a circle of 84. The thickness is 11, you see, or 11 minus 3, because we place this not at the same level with this. Yes, you see, this is in a lower position with 3 millimeters from here. Also 3 is this, so that we use this plane as a base for a sketch. Sketch F7. I eliminate these 2 circles and I project this arc. Line up, then I keep press the left button, I go here, I go tangent, I keep press the left button and I create a new arc. I must apply a zooming. I want to catch the tangency, but I don't find it, so that I place it now. Again, I keep press the left button and I go to the face. I apply tangency. I make equal these 2 arcs. I place radius of 6, excuse me. Radius is here 6. Then I place on the same vertical. You see, X is horizontal, Z is vertical. These 2 points I make equal the lines, and we ensure the symmetry now. The distance between these 2 points is half of 84. 84 divided by 2. This is radius 8. Good. I draw a line between these 2 points to have a closed area, and I hide the arc. What is the angle? We have 2 dimensions needed. The angle is 45 degrees. 45. And which dimension is missing? Maybe a tangency. Apply. You see something here? I don't see. Remove, apply. Let me try to move something here. I cannot move. You see 2 tangencies and 2 tangencies equal this 2. I don't get what is the problem. Interesting is that when we try to apply the missing dimension, we cannot find it. Remove, done. Let's continue. Finish sketch, extrude, the other direction, and the depth is 11 minus 3. Okay. The hole on this face with this center threaded, full depth, isometric profile, diameter is 8, and 2. This face is the depth. Okay, we have 2 features. This is one and the hole is the other one. We apply circular pattern for the 2 features by using this axis, not 6 but 3. Okay. Now we can go to create these void spaces by using dimensions. 5 millimeters is the thickness of the wall, radius 10, and this hole of 25 on a depth of 15. Let's do this. XY plane, F7, line from this point to inside, then a line which must be tangent parallel with this. You see, I get it. and I go to the vertical of this. I go back here, I create an arc between these 2 points with the radius of 6, not 6 but 10. I make tangent these 2. I apply the thickness of 5 millimeters, diameter of 25, but let me make this a center line, 55, 25, and 15 is this. Fully constrained sketch, finish, revolve, cut. You see what happens here. Okay, now I don't have here any extension of the thickness, and I mirror the last feature about the plane YZ. Okay, now we see the 4 holes with dimensions of diameter 9 on a circle of 90. They are through both flanges. Okay, we use this face for a sketch. I draw a vertical line here. I dimension it as 90 divided by 2. Finish sketch, hole this point. The hole is not threaded, diameter of 9, and all the way through the both flanges. Okay, circular pattern for the last feature about this axis, not 6 but 4 holes. Okay, now we can make visible this central element. Oh, and we see something wrong. Let me study this. Double click, F7. We have a parametric software, so we can change anything. Oh, 35 must be placed here. You see, 35 is inside, not outside. I make mistakes all the time, as anybody. So this is not this. This. Oh yes, this is 35. 35. Now is okay. Finish sketch, and we see that we cover this space. We can combine the two. We don't select this as first, but this. If I select this, everything becomes red. So I select this as the base body and this as the tool body. Okay. Then we take a look about fillets. You see, undimensioned fillets are radius 2. We have radius 6 here, here, and inside, and 2 millimeters the other. I select this for 6, then this one, and the inside. Plus 2 millimeters for these and this inside edges.